Hello. In this video, we'll talk about addition and subtraction of radical expression. Before we can all add or subtract rational expression, we must understand what we meant or what we mean by what is called similar radicals. Okay? So, what are similar radicals? Well, two radicals are said to be similar if they have the same index and same radicand. So remember what the index is and what a radicand is, right? So if we have a root, this here is your radicand, yeah, and this here is your index. So in this case, the index is 3 and the radicand is 5. So whenever we talk about similar, okay, radicals, we have to make sure that they have the same index and the same radicand. That is a key. Now, once you can identify that, we can say, or we can look here at some examples. If we look at the two expressions, if we have 5 times the cube root of 7 and minus 8 times the cube root of 7, these two expressions are similar, okay? Because notice that the index are the same, and the radicands are identical. The 5, okay, the 5 and the minus 8 are just coefficients that are being multiplied by the radical. So that's very important to understand, that you know what similar expressions are. So also, what is not similar radicals? If we have here, for example, 3 times the 4th root of 5, and let's say we have 7 times the cube root of 5. So although in this scenario, the radicands are the same, okay? The radicands are the same, but notice that the index here, the index are different. So in these two examples, they have different index. Yeah. The index is different in both scenarios. So you have to be very careful when you're looking at these things. Pay attention to the index and the radicand. Now, you may have also, if we have, for example, 2 times the 5th root of 8, and here we have 3 times the fifth root of 9. So in this scenario here, the index are the same, okay? But if you look at the radicand, the radicands are different. So over here now, we have different radicands. So pay attention to those, please, as you really start to combining. Now, when we add or subtract, okay, when we add or subtract, radical expressions, yeah, we simply, or it's the same as adding a polynomial. Okay? In the same way, we add polynomials. Meaning that we just combine like terms. Yeah. So, for example, if we have 5 square root of 3 minus 4 square root of 3 plus 6 square root of 3. Yeah. So notice my index, the radicand is the same for all of them. And I should write this, make sure it covers the radicand, right? Also, my index is square root, so I can just combine them. So the first thing I'll do is 5 minus 4, and that becomes, if I combine these two, becomes 1 square root of 3. And then I have my plus 6 square root of 3, and now I combine the coefficient 1 plus 6, and this becomes 7 square root of 3. Yeah. So we have 7 square root of 3 after we combine them. Now, in this first example, what I would start saying to you is always pay attention to the radicand. Can you simplify it? Okay, we have learned already, or we have seen how to simplify radicals. So it's sometimes you may be able to simplify a radical, okay? Or you will have to simplify a radical. If we look at another example, combine, if we have 3 radical 8 plus 5 radical 8. In this scenario, all we're doing is the radicands are the same, always check, and the index are also the same. They're both square roots. So we can just go ahead and add the coefficient. So 5 plus 3 becomes 8 radical 8. But pay attention now. Pay attention. Radical 8 can be simplified. Okay? So you want to make sure you pay attention. The radicand, or this radical, can be simplified. Okay? So we have here the 8 can be broken down into 2 numbers, one of them being a perfect square. So this is 4 times 2. Okay? and then we have 8, right? The square root of 4 comes out, and that is times 2. And then what you have left is the radical 2. Okay. Notice that when we take the square root of it, we pull it on the outside. And now you can multiply these two. So the final answer, we have 16 root 2. So be careful, right? Sometimes you're going to have to simplify even before you add them. Okay. So you always want to check your answer to see if there's any simplification to it. Let's look at this example. Combine, and if we have 3 radical 8 plus 5 radical 18. Now, if you pay attention to this, the index, okay, the index are not the same. The index are not the same, okay? In this example also, the radicands are different, but maybe we can simplify the radicand. So radicands can be simplified, okay? The radicands can be simplified. But index can not be simplified. So whenever the index are different, right? Whenever your index are different, that's like a no-no. Don't even attempt to do the problem, okay? So here, in this example, we cannot combine. Okay? We cannot combine. Now, here is what I'm saying, that the index, so very important, right? Notice here that your index are different. If the index are different, you cannot really play with the index to make it the same. The radicand, you can. So let's see what I mean by that. So I'm going to change that example up a little. Example. How about if I have, so combine. What if I have 3 times the square root of 8? Okay. Plus 5 times the square root of 18. So notice here, my index are both square root. Okay, my index are both square root. So once the index are the same, then you can try to simplify. Now, if you notice here, my radicands are different, but 8 can be simplified. We know this. So we can simplify this. We can simplify. Okay. And this becomes 3. The root 8, we know, can be broken as 4 times 2. Plus, and notice that this here can also be simplified. Okay, can simplify. And if we simplify that portion also, the plus sign comes down, the 5, the radical, and 2 numbers multiplied to give 18, one of them a perfect square, that would be 9 times 2. So notice that when I choose my factors also, something to observe, right? We know that the 4 will be extracted out because we know the square root. But look at what's other factor, right? The other factor you have is a 2. Okay? So they must have that in common. So we have 3, okay? The 4 Remember, this can here can be rewritten as square root of 4 times square root of 2, right? We can also here square root of 9 times square root of 2. And that's when I say that the 4 comes out, and that becomes times 2. Okay, and what's left is radical 2. Okay, plus 5. The 9, the root of 9 is 3. And what's left is my radical 2. Yeah. So now we can multiply these two, right? Those coefficients, they are now coefficients. So 3 times 2, this becomes 6 radical 2 plus 5 times 3 is 15 radical 2. So observe that my index is still a square root. Yeah. And the index will not change throughout the problem. The index will not change. And now my radicands are the same. So I can add the coefficient now. Add the coefficient. And if we add our coefficient, 16 plus 6 plus 15 becomes 21 radical 2. And my radicand here is 2. That cannot be simplified. So here is my final result. Look at another example. So combine. If we have 4 radical 8 minus 2 radical 50 minus 5 radical 72. Yeah. So notice my index are all the same. That's the first start. If my index are the same, this we're fine. We can simplify this more than likely. Okay, so what are the factors of 8? We're one of them, right? We have to simplify all of the radicands because they're different. And sometimes you can, sometimes you will not be able to. Yeah. So if we do this, this can be simplified, this can be simplified, and that can be simplified. So we have 4 radical 8, we know can be simplified as 4 times 2. Okay, minus 2 radical 50 now. So here's a, try to pay attention, right? The 4 here will be extracted out, so the 2 will be left. So is there any number times 2 that give 50 where that other number is a perfect square? And then we have 25 times 2. Okay. Minus 5 radical, okay? What times 2 gives 72? Well, 36 times 2. So, and not all 3 of them had to be simplified, right? Not all 3 had to be simplified. So now the 4 from the first term will be extracted out. So we have 4 times this 4 here, the square root of 4, when you take it out, becomes 2. So you're left with root 2, right? Minus 2, this 25 here, when you take the square root out, becomes 5. And that what is left is root 2. Minus 5, this 36, when you take it out, becomes times 6. And what is left is root 2. So multiplying the coefficients now, okay, 4 times 2, then the negative 2 times 5, and then the negative 5 times 6. So if we multiply them, okay, 4 times 2, that is 8 root 2, 2 times 5, so that becomes 10 root 2. 5 times 6, that becomes 30 root 2. So we have all our index are the same. Our index are the same, okay, which didn't change. And now my radicands are all the same. So all I have to do is look at my coefficients now, okay? 8 minus 10, and that becomes minus 2, okay? All I look at is the coefficient. So minus 2 radical 2, and then we bring down the minus 30 radical 2. And then once again, I look at my coefficients, okay, because I know the index are already the same. Yeah, I look at my coefficient, and minus 2 minus 30, that becomes minus, yeah, 32 radical 2. And here is our final answer. Okay, that's our final answer. So we can also have examples where we have variables in them, right? The key point is to make sure that the index is the same for all of the radicals. So the index here is square root, so meaning it's a 2. And the radicands in these examples are all the same. So we can just combine, right? We can just combine our coefficient slash variable here. So if we look at the first two, 5x plus 4x becomes 9x. So here we have 9x square root of 2. And then we have to subtract 1x from that. So if we combine these two coefficients, keep in mind there is an invisible 1 here, right? So 9x minus 1x or minus x, that becomes 8x square root of 2. And look at the radicand. Can you simplify 2? And the answer we know to that is no. Okay, cannot be simplified. So our final answer is 8x times the square root of 2. Now, what happens if we have the variable as part of the radicand, right? What happens if we have the variables as part of the radicand? So example, if I ask you to combine, let's say, 2 radical 50x squared now, and the x squared is under the radical, minus 8x radical 18 minus 3 radical 72x squared. So a couple of things to notice. I mean, the index are all the same. That's the most, one of the most important parts too, right? The index has to be the same. So this index is the same as this index is the same as that index, okay? All of the index are the same. So if the index are the same, we're good. Now we have to simplify the radicands because the radicands for them are different, okay? The radicands are different. Now 2 of the radicands are the same, but we can combine those. However, I wouldn't, because I noticed that the exponent here is a 2 and there it's a 2. So this definitely can be simplified. So just to do a refresher, right? The index usually have to go evenly into the power, right? That's what we have seen before. So I could simplify under here and here and even this one here. Those radicands can be simplified. So we have 2, the radical, okay, 50, and let me write it more over here. 2, so this one will be this. The radical of 50 is the same, the two numbers is 25 times 2. Yeah. 25 times 2. And x squared will stay where it is. Okay, so we write x squared. Why? Because remember, the index here is 2. Okay. You can also think of this as I used to do before. You can break it up into 2 radicands if you want, radical times a radical. So the 25 goes here, the 2 goes here, and then also your x squared will go under here because that can be simplified. Okay, so this breaks up into 2 of them. Minus 8x, and if I make 2 radicals as I did before, so I need some room, so minus 8x, the 2 radicals would be 9 times 2. Yeah, 9 times 2. Minus 3, and if I make 2 radicals once again, right, 2 numbers will be 36 times 2. And the x squared will stay with the 36 because I know that can be simplified. So each one of these radicals here will go away because they're perfect squares. Okay, those radicals will go away. So this one here I broke up into these two, this one here I broke up into that two. Now let's see what happens. So I have my 2 comes down. Now the root of 25 is 5, and the root of x squared is x. Okay, so if you're wondering, just to refresh, okay, the square root of x squared is the same as x squared raised to the 1/2 power, and 1/2 times 1/2 times 2 is just 1, and that's why I'm getting just x. So this is like a little refresher, okay, as to how I'm getting my x there. And then we have the square root of 2 left. So minus 8x, this here comes out to be 3, and then I have root 2 left, minus 3, right? So this portion here comes out to be the square root of 36 is 6. And make sure you put a times there. Make sure you put a times because you don't want it to write as 36. So 3 times 6. And if you take out the square root of x squared, that's x. And radical 2 is left. Yeah. Now, if we combine these two, and then these two, and then these two, we multiply. So 2 times 5x, that becomes 10x root 2 minus 3/8 or 24x root 2. 3 times 6 is 18x root 2. So my index are all the same, didn't change, okay? And my radicands are now all the same. So now I can just combine my term on the outside. So we have 10x minus 24x, that becomes minus 14x root 2. And I bring down my minus 18x root 2. Yeah. Now I combine the minus 14x and the minus 18x. And if I do that, I end up with minus 32x root 2. Okay? And here we see that this here, okay, is our final answer. So in my next example, we have some letters on the radical. So we start out by looking at the index, or the index the same. And we see the index for both radicals are 3. So I believe that we can simplify here. So let's see if we can, right? Once the index are the same, we can attempt to simplify. So this one here, I know can be simplified because 8, I know, is the two numbers. So these will be 2 cube root. I'm multiplying, okay? Will be 4 times 2. Now, 4 here is divisible, not divisible by the index 3. So I have to write that as a cube times a, okay? And the index here is, the power here is smaller than my index, so that will not be able to simplify it. So this here, by simplifying, I get these two radicals. Now plus, so the 11a stay outside, and what two radicals am I going to simplify this to? Well, 27 can be 9 times 3, okay? 9 times 3. And this a has a power of 1, so that is less than 3, so that stays with that 3. And the power here is also less than the index, so that we know we'll be able to simplify it, so that stays over there. And as I said before, the reason I like to split them up, because I know everything here will be simplified, everything in that radical will be simplified. Okay? So we have the 10 stays, okay? Made a mistake here because we're talking about cube root. So yes, I didn't observe that we're talking about cube root here. So this here is not correct because we don't know the cube root of 4. So let's leave that so you see the number here. We're referring to cube root, not square root, right? So it happens that 8 is a perfect cube, right? So that was a mistake. Okay, so let's erase both roots. So they still have to be simplified, but we're talking about cube root. Okay? So 8, we know the cube root of 8, so we don't have to simplify the number. However, a to the 4th, so we have a cube and times a to the 1. And since the b power is a 2, that's always cannot because it's less than the index. Okay. Same thing we'll do over here. We need cube root of 27. So 27, we know the cube root of 27. The power of the a, I said, is a to the 1. So it's smaller than the index. So that cannot be simplified. The power of the b is a 2, so that cannot be simplified either. So we put it there. So remember, we're talking about a cube root, okay? And if the powers are smaller than the index, they cannot be simplified. So now we can simplify this. So as you see, right, you have to be careful. Pay attention to the index because you can make a mistake just as I did, okay? So the cube root of 8, this becomes 2, so times 2. And the cube root of a cube is a. And we have left the cube root of ab squared plus 11a. The cube root of 27 is 3, so times 3. And we have left here the cube root, and I keep leaving out my cubes, the cube root, right? The cube root of AB squared. If I multiply these two now, 10 times 2a becomes 20a. The cube root of AB squared, yeah, plus 11 times, well, let's multiply it out. 11 times 3 becomes 33a, and we have the cube root of AB squared. Yeah? The cube root of AB squared. So we have now, we can combine the coefficients slash variable. So 33a plus 20a, 33a plus 20a becomes 53a, and we have the cube root of a to the 1, b to the second, right? So as I had pointed out before, look at the index. The index here is 3, okay? Whereas the power here is a 1, and the power here is a 2. If those powers are smaller than the index, there is no simplification. If it's exactly the same or bigger, then we can simplify. So this is our final answer. Okay, here's our final result. Okay. So once again, we have to try to see the simplifying of the radicals. And okay, you will notice that simplifying, if you don't know how to simplify radicals, you can struggle. So it's very important that you try your best to simplify or get better at simplifying radicals. Okay. Very important. So as always, at the end of my videos, I say to you, always try to practice more examples. The more examples you practice, the better is it for you. Okay. So see you in my next video.